projects. In this video, we are going to explain about the project titled Combined RF-based Drone Detection and Classification. Introduction. Our project harnesses advanced radio frequency RF detection technology. We aim to create a system capable of detecting and classifying drones based on RF signals. This innovation enhances security and safety measures by providing a powerful tool to identify and categorize drones accurately. Drone usage is on the rise, addressing effective monitoring and management. Unauthorized drones present security threats in sensitive areas such as airports and public events. Our project addresses this urgency, offering a solution to proactively safeguard critical infrastructure and public spaces. We integrate RF signals and visual data for drone detection and classification. This fusion strengthens security measures by providing a comprehensive approach to identify and categorize drones, mitigating potential threats effectively. Objective. Our primary objective is to bolster security by proficiently identifying and categorizing drones across diverse situations. This effort is vital in countering potential security threats posed by drones, ensuring a safer environment. We leverage the power of YOLO V5 for real-time drone detection in images and employ DRNN to scrutinize drone behavior patterns in sequential data. This fusion of algorithms significantly enhances security by providing accurate drone identification and a deeper understanding of their temporal dynamics, thereby improving their classification. Our ultimate aim is to construct a resilient system capable of efficiently detecting and classifying drones. This system contributes to an elevated level of security by ensuring the swift and precise identification of drones, leading to better risk management and security measures. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. The project imports essential software packages and libraries required for various tasks. These packages include NumPy, used for efficient numerical operations and array handling, Pandas for data manipulation and analysis, particularly for tabular data, TensorFlow, a deep learning framework used for building and training neural network models, Matplotlib and Seaborn, utilized for creating data visualization and plots. Scikit-learn offers tool for machine learning model development, evaluation and pre-processing. Transformers, used for natural language processing NLP tasks, including tokenization and transfer learning with pre-trained models like BERT. Exploring the data set. This step involves gaining a comprehensive understanding of the data we will be working with. We explore two data sets, drone detection data RoboFlow and drone detection annotation based. This exploration includes examining the dataset structure, attributes and contents, which is crucial for data preparation and model development. Image processing. Image processing is a critical component of our project. Here are the key tasks within this module. Appending the image and annotation file and images. This step combines image data with annotations to establish ground truth for training our model. Converting BGR to RGB. Images often come in the BGR color format, but we need RGB for processing. This conversion ensures compatibility. Creating the mask. Creating mask assists in identifying specific regions or objects within the image. Resizing the image. Resizing images to a consistent size is essential for uniform processing and compatibility with the chosen model. Data augmentation. Data augmentation is a technique to diversify the dataset for better model training. This module includes randoming the image, introducing randomness like flips, brightness adjustment and noise to generate more varied data. Rotating the image, applying rotations to images to simulate different orientations. Transforming the image, applying transformations like scaling and shearing to add variability. These techniques help improve the model's ability to generalize to different real-world scenarios. Data extraction and splitting the data. This step involves extracting relevant information from the dataset and dividing it into two subsets for training, validation, and testing. Proper data splitting ensures that the model can be trained effectively and evaluated accurately. Installing the packages required for YOLO v5 in Colab. To work with YOLO v5, we need to set up the necessary packages and configurations in Google Colab. This includes installing dependencies, setting up the runtime environment, and ensuring compatibility with YOLO v5 model training. Processing the data based on YOLO v5 model. This module involves formatting the data in a way that is compatible with the YOLO v5 model. YOLO v5 requires specific input data formats such as converting annotations to YOLO format and organizing the dataset for training. Building the model in Colab. This is a crucial step in the project where we construct the machine learning model. We have two components, YOLO v5 and DRNN. YOLO v5 is the chosen model for real-time object detection, including drone detection. DRNN, Deep Recurrent Neural Network. DRNN is used for analyzing sequential data related to drone behavior patterns. Training the model. This module involves training the previously designed model using the training dataset, which was prepared earlier by splitting the data into training and testing sets. The model learns the patterns and features in the training set and then validates its performance on the testing set to ensure it generalizes well to unseen data. Building the model with YOLO v5. YOLO v5 You Only Look Once version 5 is an object detection model that can detect multiple objects in an image or video frame. In this project, YOLO v5 is utilized to detect license plates from the given input, which could be either an image or video frame. The YOLO v5 model is trained to recognize license plate and provide bounding boxes around them. Flask framework with SQLite for sign-up and sign-in. Flask is a lightweight web application framework in Python, and SQLite is a simple and easy to use database engine. In this module, Flask is utilized to create a web application where users can sign up and sign in. SQLite is used to store user authentication data securely. Users can create accounts to interact with the application. User gives input as image or video. So here the user will give the input as an image or will upload a video. The given input pre-processed and trained model is used for detecting the license plate. The input, image or video provided by the user needs to be pre-processed before feeding it to the YOLO v5 model. Pre-processing involves resizing, normalization, and any other necessary transformations to ensure compatibility with the model's input requirements. The segmented each object and put bounding box. Once the license plates are detected, bounding boxes are drawn around them to highlight their location in the original image or video frame. Additionally, the detected objects' license plates are segmented, meaning they are isolated from the background and other elements. Final outcome is displayed. The final outcome of the process, which includes the original image or video frame with bounding boxes around the detected license plates and potentially segmented license plate images, is displayed to the user through the web interface. This allows the user to visually identify and verify the detected license plates. Execution. To execute this project, first we need to open the code folder which contains the project source code file. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in the Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. Here I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flash framework will host the application locally at the default address, which is this, and port, which is this. Now copy this local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flash framework. Now click on sign up button. If we are a new user, we need to register first, but I have already registered, so click on sign in button. This is the sign in form. Here we need to enter the username and the password which we have created. So I'm entering the username and the password and click on sign in. So this is the homepage of the project. Here we need to upload any image, and after uploading the image, the drone will be detected with the bounding box and we will get the license plate also. Now let us upload an image. Open. Click on upload. So here we can see that the drone is detected and we can see the bounding box over the drone, and we have the name for the drone, that is DJI Phantom, and we even got the probability score. Now let us upload one more image. Open and click on upload. So here we can see that this drone is also detected with orange color bounding box, and we got the name as DJI FPV, and we got the probability score, that is 0.96. Let us upload one more image and open. So here we can see that this drone is also identified by an orange bounding box, and we got the name as FPV, and we also got the probability score. So in this way, by uploading the image, the drone will be detected with the bounding box and we will get the probability score. The conclusion of the project is YOLO V5 is a state-of-the-art real-time object detection system. In this project, YOLO V5 has been successfully integrated and optimized for the detection and classification of drones. YOLO V5's efficiency allows for real-time drone detection, enabling rapid and accurate identification of drones within a video stream or series of images. By leveraging YOLO V5, the system significantly enhances security measures by providing a fast response to potential drone threats. Shift in accurate detection is critical for effectively mitigating security risks associated with drones. DRNN is a type of recurrent neural network capable of modeling temporal, sequences effectively. The project employs DINN to analyze the temporal dynamics of drone behavior. This involves studying how drones move and behave over time, enabling a deeper understanding of their patterns and activities. Analyzing these temporal dynamics using DINN yields valuable insights that contribute to a more refined and accurate classification of drones. Flask is used to develop a web-based user interface, providing a simple and intuitive platform for users to interact with the system. Users can easily upload images or videos through this interface. The uploaded content is then processed by the system to identify license plates and segment objects.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.